To calculate the percent mass carbon, what we're going to do is figure out the total mass of the entire formula, put that in the denominator, and then separately figure out the mass of just the carbon inside that formula, and put that in the numerator. We divide the top by the bottom, times it by 100, and that's it. With this problem, I'm going to do some rounding. So I'm taking carbon, I'm going to round and assume that the atomic mass of carbon is 12, which is not completely correct, depending on how many decimals you go out on your periodic table. I'm just trying to keep things simple, okay? So this formula has 17 carbons in it. Each carbon weighs 12, so I multiply 17 by 12. Separately has 21 hydrogens. Each hydrogen weighs 1 on the periodic table. Again, I'm just rounding to keep things simple, okay? So I add 21 to that, multiply by 1. Nitrogens weigh 14, and there's only one nitrogen in this formula, so I add 14. And then each oxygen weighs 16, and there are 4 oxygens in this formula, so I add 4 times 16. So this is the entire numberage that we will add up in order to get the molecular weight of this entire compound. You'll notice that I brought them down here piecemeal. 17 times 12 is 204, then I've got the 21, the 14, and 4 times 16 is 64. Okay, so you can kind of see where I got the final answer, hopefully. So if I add all these numbers together, the answer that I got was 303, being the molecular weight of the entire compound. Now, I put that in the denominator right here as 303. What of the 303 is carbon's mass? That is the mass of just the carbon. Yeah, you can see it's just this term, 17 times 12, which is 204. So that is the mass of just the carbon inside our formula, okay? So I take the 204, divide by 303, and multiply it by 100 to get a percent. And the answer that I ended up getting is 67.3%, depending on how you round. And I'm not getting super uber uptight with the significant figure rules right here, okay? Now for part B, I'm not going to work it all out for you. Suffice it to say, you do the exact same method. I ended up getting a total mass for this compound, vancomycin, a very powerful antibiotic, as being 1,316 grams per mole, or AMUs. And the mass of just the carbons, 55 times 12, coming out to 660. You divide the carbons by the total mass times by 100. The percent carbon of that mass I ended up getting was 50.2. And hopefully that all makes sense.